Hi, my name is Marta Zameda. I'm an applications engineer here with Agilent Technologies. One of the test challenges engineers have today is in demodulating LTE-Advanced interband carrier aggregation signals. In this short video, I'll show you how Agilent addresses this test challenge with our signal generation and analysis solutions. Carrier aggregation is one of the major features of LTE-Advanced that allows two or more LTE carriers to be aggregated to create wide transmission bandwidth of up to 100 MHz in order to achieve the LTE-Advanced target peak data rates of up to 1 gigabits per second. By definition, these aggregated carriers, also called component carriers, can be contiguous or non-contiguous, and both within a single frequency band, also known as intraband, or multiple frequency bands, also known as interband carrier aggregation. Interband carrier aggregation is the most realistic deployment scenario since spectrum allocation for operators is often scattered across multiple frequency bands. It's also the most challenging, especially for user equipment, since it requires multiple transceivers being operated simultaneously to cover the multiple bands. One of the major physical layer test challenge is demodulating these component carriers simultaneously, since the frequency band separation in the interband scenario is wider than the IF bandwidth of any commercially available signal analyzer. What you will learn in this video is how Agilent addresses this test challenge with the 89600 VSA software, along with dual X-series signal analyzers or the N7109A multi-channel signal analyzer. Our setup today includes two MXG signal generators. I have the top MXG generating two component carriers at 800 MHz frequency band, and I have the second MXG transmitting three component carriers at 2100 MHz frequency band. I have two synchronized MXA signal analyzers, each one of them connected to the right frequency of the MXGs. And I have a single instance of the 89600 VSA software that's doing the capture from the two MXAs, and it's doing simultaneous analysis on all of the 5 component carriers from the 2 frequency bands. Even though the demonstration today is focused on the downlink, the same features and capabilities are also available for uplink analysis. On the 89600 VSA software, I have selected LTE-Advanced application, and under the demod properties, I select the number of component carriers to be 5. I then specify the correct input and the current frequency offsets for each component carriers. So as you can see, 2 component carriers are at 800 MHz using input number 1, which is the top MXA, and I have 3 component carriers at 2100 MHz using input number 2, which is the bottom MXA. The settings for each component carrier can be specified independently by selecting a component carrier on the Common tab, and then specify the settings on the other tabs, such as the signal bandwidth. The demodulator then performs simultaneous but separate demodulation of each component carrier, and measurement results are provided for each component carrier. The bottom 2 traces show the spectrum for the 2 frequency bands, and the top 5 traces show demodulated results of component carriers 0 through 4, and for each component carrier, I am overlaying 3 trace windows. The frame summary trace showing all the active channels along with their EVM, power, and modulation formats, a constellation diagram, and a detected allocations time trace that shows the resource allocations in a 2-dimensional grid with frequency on the vertical axis and time on the horizontal axis. All of these traces are color-coded according to the channel type, and the frame summary trace shows all the channels and their corresponding colors. As you can see, the different component carriers have users with different modulation formats, and some of them only occupy a portion of the available resource, whereas some of them, like component carrier 2, occupies all the available resources. I also want to point out there are more than 40 available trace data for each component carrier, including various EVM traces and summary tables. What I'm showing here is just 3 out of the more than 40 available traces. As I've just shown, Agilent, with its industry's most comprehensive LTE-Advanced solution, can help you test your most challenging LTE-Advanced designs. For more information on Agilent's LTE-Advanced test solutions, please visit our website. Thank you for your time.